Hello everyone, the topic of my presentation is gasifiers. The topics I would cover in the presentation are firstly what is gasification, then I would explain the different gasification process, then the types of gasifier. There are two types of gasifier, fixed bed gasifier and fluidized bed gasifier. And at last I would cover the applications of gasifiers. What is gasification? It is the thermochemical process that converts carbon-based raw material into producer ocean gas. It converts fossil fuel-based carbonaceous material into carbon monoxide, hydrogen, and carbon dioxide. This is achieved by reacting the material at higher temperature with a controlled amount of oxygen and steam. What is the difference between producer and syngas? Producer gas are generated at low temperature. It is a mixture of combustible hydrogen, carbon monoxide, and methane, and also non-combustible gases like nitrogen and carbon dioxide. Syngas, these gases are generated at higher temperature above 1200 degrees Celsius. These are the mixture of hydrogen and carbon monoxide gas. This gas can be produced from producer gas by thermal cracking and catalytic reforming. The table shows the typical composition of producer gas. Different gasification processes. There are four processes: combustion, reduction, pyrolysis, and drying. This is not necessary that these processes will be in the same order in all different types of gasifiers. Combustion process. Combustion is the combination of combustible gases with oxygen to release heat, producing water vapor and carbon dioxide as waste products. It is exothermic process. Then drying process. Drying is what removes the moisture in the biomass before it enters pyrolysis. All the moisture need to be removed from the fuel before any above 100 degrees process happen. Now we have the third process, pyrolysis process. The word is coined from the Greek derived element pyro, that means fire, and lysis, that means separating. Pyrolysis is the application of heat to raw biomass in an absence of air so as to break it down into charcoal and various tar gases and liquids. It is an endothermic process. The process typically occurs at temperature above 400 degrees Celsius. It can be noted that extreme pyrolysis, which often leaves only carbon as a residue, is commonly known as carbonization. It is an irreversible process. Now we have the last process, reduction process. Reduction is the direct reverse process of combustion. Reduction in a gasifier is accomplished by passing carbon dioxide or water vapor across a bed of red hot charcoal. The carbon in the hot charcoal is highly reactive with oxygen. Through this process, carbon dioxide is reduced by carbon to produce two carbon monoxide molecules, and water is reduced to carbon to produce hydrogen and carbon monoxide. Both hydrogen and carbon monoxide are combustible fuel gases, and those fuel gases can then be piped off to desired work elsewhere. This is just an overview about the different processes that we have discussed. It tells about the temperature range of each and every process and also the reaction that occurs during each and every process. Types of gasifier. There are two types of gasifier, fixed bed gasifier and fluidized bed gasifier. Fixed bed gasifier that contains updraft, downdraft, crossdraft gasifier, whereas fluidized bed gasifier that contains circulating fluidized bed gasifier and bubbling fluidized bed gasifier. Now I would be explaining all the types of gasifiers one by one. The first type of gasifier we have updraft, or also known as counter current gasifier. In this type of gasifier, biomass fed move downwards and gasifying agent move upwards to biomass through the fixed bed biomass. Ash is removed either as dry ash or as slag. Combustion takes place at the gasifier bed bottom and hot gases pass through reduction, pyrolysis and drying zones of the bed. Thus, the amount of oxygen fed for the combustion reaction is carefully controlled such that the temperature of the combustion zone does not reach the slagging temperature of the ash, causing operational problems. Product exits from top at low temperature. The disadvantage of this gasifier is excessive tar in the product gas is formed. Downdraft, or even known as co-current gasifier. In this type of gasifier, biomass and air is introduced from the top of the gasifier. Producer gas leaves from the bottom. Biomass passes through drying, pyrolysis, combustion and at last reduction zone. The advantages of this type of gasifier is that producer gas has low tar content and it is suitable for gas engines. The disadvantage is oxidation zone position is critical. Cross draft gasifier. The biomass fed move downwards while the air is introduced from the side. The gas is withdrawn from the opposite side where the gas is introduced. The crucial difference is that the air will be entering from the side of the reactor rather than from the top or the bottom. The startup time for this reactor is relatively short and high temperatures can be attained using this type of gasification. This type of gasification does not handle fuel that has high tar content. The ash bin fire and reduction zone in cross draft gasifier are separated. Poor CO2 reduction occurs in this type of gasifier. Producer gas produced from this type of gasifier has low calorific value. Fluidized bed gasifier. In a fluidized bed gasifier, solid fuel is broken into small pieces and introduced over a gas distributor plate through which oxidant flows upward. Hence, the fuel particles are suspended by the upward moving oxidant and undergoes turbulent movement including back mixing. It have uniform temperature distribution in the gasification zone. The turbulent mixing promotes a uniform temperature in the fluidized bed because fluidized bed gasifier would plug if ash were to melt. The bed temperature must be below the ash melting or slagging temperature. The feedstock is dried and pyrolyzed rapidly to release its volatile metal, which burns and supplies the heat for the endothermic gasification reaction. The raw syngas flows through a cyclone to remove particles. The removed particles containing char and ash are recycled to the reduction zone. Fluidized bed gasifier typically operates at temperatures between 900 to 1050 degrees Celsius, which is below the softening point of ash. The first type of fluidized bed gasifier is the circulating fluidized bed gasifier. A circulating fluidized bed gasifier design operates at a high velocity and incorporates recycling of the jar and bed material, resulting in complete mixing regardless of feedstock size. Generally, the circulating bed designs are more flexible but are still limited by the amount of very fine material that they can process. Technological surveys show that up to 95% of the pollutants can be absorbed before being emitted into the atmosphere. Bed material is circulated in the reaction vessel and cyclotron separator where the ash is removed and the bed material charcoal is returned to vessel. It operates at a higher pressure used for gas turbine. Gas velocity decreases. It also decreases the char loss. Disadvantage of this type of gasifier is the size of fluid particles determine minimum transport velocity. Heat exchange is less efficient than in bubbling fluidized bed system. Temperature gradients occur in the direction of solid flow. Now the last type of gasifier we have bubbling fluidized bed gasifier. In this type of gasifier, the gasifying agent can be supplied in two different zones. The first zone is within the fluidized bed in order to maintain the required temperature. The second zone is located above the bed, which aims to convert entrained unconverted volatiles and char particles into fuel gas. It consists of a vessel in which the gasifying agent is introduced upward at a velocity fast enough to agitate the bed material which sits at the bottom part of the gasifier and to maintain the required temperature. Biomass is fed from the side into the hotbed, where devolatilization occurs. Char particles and volatiles are gasified and cracked by contact with the hot fluidized bed. Additional gasifying agents can be supplied in a second zone located above the bed, with aims of converting entrained unconverted volatiles and char particles into fuel gas. A final flue gas with low to medium tar content is produced. Ash is separated from the syngas by solid separation units downstream. The advantages of this type of gasifier is it yields a uniform product gas. It exhibits a nearly uniform temperature distribution throughout the reactor. It is available to accept a wide range of fuel particle size including fines. A high conversion is possible with low tar and unconverted carbon. The disadvantage of bubbling fluidized bed gasification are that a large bubble size may result in gas bypass through the bed. The last topic of my presentation is application of gasifiers. Syngas or producer gas can be burned to create heat, steam or electricity. It can be converted to methane and fed into natural gas distribution system that is used for transport of natural gas through local or regional gas network for the purpose of supplying customers. Syngas can be converted into methanol, ethanol and other chemical and liquid fuels. Methanol produced through gasification can be further refined into biofuels, example gasoline, jet fuels, etc., with addition of vegetables oils or animal fats. These are the references of my presentation. Thank you for your attention. End of the presentation.